All right, so let's talk about the basic ways it works, okay? There are other easier ways to get in, but we're going to talk mostly about an exploit. Okay? An exploit is a coding problem. We'll call it a weakness in the code. The exploit is the actual, is when you actually do it. Yeah, the vulnerability is that it's there. The exploit is when is the thing that does it. Okay. I'm going to explain this right now. The whole idea here is if there is an exploit, there's a vulnerability. So I call this a vulnerability. And I might as well not put that allows. An exploit means that there's a vulnerability in your code. So I put all sorts of stuff on here. In your code allows a hacker to run their own code. Okay? Their own code is the exploit. Okay? So the vulnerability is like the open door. The exploit is the way they get in. That seems reasonable, right? So here's how they all work. And this is how the heartbleed one works. And I told you it was a non-validated, what did I call it? A non-validated field. It's always a non-validated field in some way. Okay? The port is part of the vulnerability. So think about it here. Let's say my web server here. This gets really nice and complicated, right? So let's say the way that lets them hack into the baby monitor is a vulnerability in the baby monitor. Okay, so they send something to the baby monitor that allows that code to be executed. Yeah, it accepts that code. So the people that did the baby monitoring didn't deny it. Okay, so that's the vulnerability. The port opening was the thing that just allowed the rest of the whole world to get to it. If you think about people on the internet, they have to do business on the internet. And so they have this program running, this heartbeat, on their secure HTTPS connection. It's just there and running. And they didn't realize that there was, where was it? They didn't realize there was this non-validated code, and so there's like a back door going, okay? So they were already open to the internet, and they're just stuck.
So it's not port versus code, it's all together.
Yeah, it's all a combination. So it's not just port versus, it's not port or code, it's the whole combination of everything, okay? So basically the hacker must be able to access the vulnerable, and I'll just call it a host, right? Okay, we understand that. So it could be a client or a server. What this is called, what these are, 99.9% of these, well, anyway, it's just about non-validated code. One of the main ways is what's called a buffer overflow. Okay, and that was what caused this heartbleed one. The way a buffer overflow works is in your code you declare variables, right? What if I declare, what do you guys do, C++? I need to declare a string variable that's going to hold someone's last name. Okay, how would I declare that? str, do I put a space?
No, it's actually, it's spelled out.
Oh, string,
Whole word.
string, space,
Last name, all one word.
last name,
Well, you can initialize it or not.
Well, I don't know.
If you initialize it, it would be,
Do I just put Haynes then?
quote, or,
So I put Haynes in it. Okay, now what tells me how long that string is?
in C++, it could be,
Y'all are telling me the string can be as long as I want. Well, here's what happens. If I have an open network port, okay, and one of my fields is, how do I input it, by the way? Like if I want someone to input it, so I put in CN, last name, and that'll be like someone types it in.
yeah,
And I put the semicolon, right? Where get your semicolon?
I'm gonna say it's double arrows.
Oh.
In between C and last name.
This is like.
Okay, no, we got to get it right. Okay, so this is like someone would type that into a keyboard, right?
Yeah, we'd say.
So they type it into the
and
keyboard.
then we catch it.
Okay, here's what happens. So you're trying to catch this, whatever they typed into the keyboard. So they do keyboard, and whatever was in the keyboard goes into last name. Okay? Here's the problem. There's a certain amount of memory allocated to the keyboard. Okay? So we'll say X bytes allocated to the keyboard. Okay? Because you know when you type on the keyboard, it's 8 bits for every key press. And so they might have, anytime someone types, let's say 16 characters, what came from the keyboard is then flushed into your variable. Have you guys seen that stuff happen where you have to flush the cache? Y'all might not be getting into that. If you've done any file access, it does the same thing. So you input a file and you have to, but as you're reading it, don't you read it in chunks? Usually it comes in chunks. So you read, usually keyboard doesn't, but usually you flush the keyboard, droop, 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 and it sort of drips into here. Because the buffer is only so long. It might hold, I don't know, let's say 4 bytes. So it holds 4 characters at a time. And if they go 4 characters, then I need to take those 4 and dump them into my variable. This is really like close to the metal programming, by the way. That's what you did back in my days. But anyway, so it's a little chunk at a time. What the hacker does, the hacker is just going to add more bytes than the buffer holds. Okay? So, let's say, for example, the buffer is 4 bytes. The hacker sends, and let's say, 16 bytes. All right? So there are 12 extra bytes. You have a vulnerability if those 12 extra bytes go back to the computer. Here's the scary part. So I had here, what was my code? So I had CN, last name, okay? And they sent in all this extra data. The extra code ends up overwriting my program. That is awesome. So remember, what happens is, I'm expecting just from the keyboard, right? So someone has hacked a keyboard, and they've made it so over this connection to your keyboard, instead of only sending 4 bytes at a time, it all of a sudden dumps in 16 bytes. Okay? What normally happens is it crashes. Okay? It'll just go crash, unexpected, whatever, something, boom, boom. The program crashes. It'll crash. The program will just crash. It's protected memory and all that stuff, and everything's fine. Now, here's the thing. if they tailor the code, so your computer actually does something, then they've got you. Okay? That's the exploit, is this. All right? Are we good with that? So what they can do is these 12 extra bytes, they can form them in such a way, for example, that it might instruct your computer to go to download some file, execute something on your command prompt, you know, these various things. Change something in your registry, right? There's all sorts of fun things they can do. There's 12 extra bytes, or, you know, it might be longer. Usually these happen in several steps too. So there'll be a simple overwrite somewhere. Yeah. They'll call it to do something else, and then that will call it to do something else. So usually this code they do is that you go somewhere and download something else, okay? It might be stuff as simple as, well, anyway. So they want to do that. We'll say here's something nasty. So it's something you don't want to do. So if we look back here at the baby monitor, the way they hacked in is they sent the wrong kind of data or too much of some kind of data down here in the command where you would normally just listen to the baby or talk to the baby. They sent something that was like, this is not a normal sound file or normal sound. They've tailored the code enough that it doesn't crash the baby monitor. It instructs the baby monitor to do some special code. Okay? So they reprogram the baby monitor basically. And so now the baby monitor will allow them to hack in. All right? So same here with the heartbleed, right? So there's this heartbeat ping going on. They can send a bad set of data in that field, and the server freaks out a little bit, and it's like, I don't know, it throws up, like I threw up in my mouth, right? Anyway, it throws up something, and what comes back is some unencrypted data in the server's memory. That's awesome. Oh, I'm sorry. Come on, you shocked, you startled them. They're like, bleh, bleh. Here you go. Well, that's what this one is. That's not this one. Yeah, they're making a program that goes inside the extra space. And that's every single, or just about every exploit you see anymore. Okay? This happens all the time.